Hello. Hi, it's Paul from Paul Tutors Maths. Thanks for joining me. If you haven't been before, welcome. Welcome to the session. Subscribe to my YouTube. You'll get a notification every day when we start. Follow me on Instagram, Paul Tutors Maths. I'll post some A-level maths content. Let's get started. Two questions today, one AS level and one A level, like always. Post them on Instagram the day before. Only other thing to say today is try them. Try them with me. Get paper, get a pen, sit down. This is our math session. This is a boost for the day. And you get the most out of it if you try it yourself. So sit down with me and let's go. Drop my pen to start with. That's a good start. Okay, nice one. Factor theorem. Let me write it out. Well, let me write out the question first. 4x cubed minus 12x squared plus 2x minus 6. I'm not going to do a full lesson or chat on factor theorem. I'm just going to do it and then maybe go back and explain if I've got time. Factor theorem is that if, well, let me just write it out first. If f of a equals 0, that means that x minus a is a factor. Not sure why I changed between small letters and big letters, but there you go. Let's put a box around it. That is factor theorem. So sometimes people maybe don't, I don't know, sometimes people maybe don't jump in and know actually what the factor theorem is. They'll just do the work. That's what factor theorem is. In terms of a legwork, here they've said show that, use factor theorem to show x minus 3 is a factor. So here, a equals 3, right? Because it's x minus 3, or a is 3. Therefore, we're looking to show that f of 3 equals 0. That's our life dream. That's our goal. Well, let's do f of 3. Not sure why I used a capital here and a small here. Let's go back to the small notation, okay? Maybe just use capital just to really emphasize the theorem and get it through to you, but we're going back to small notation now. So f of 3 equals 4 times 3 cubed minus 12 times 3 squared plus 2 times 3 minus 6, which equals 4 times, that's going to be 27, minus 12 times 9, what are we saying, 108 is that as well? Possibly, stick with that for now, plus 6 minus 6, 4 times 27, if your mental math is better than mine this morning, well done to you, that's also 108. So indeed, a equals 0. Therefore, x minus 3 a factor by factor theorem. That's A. We'll do a recap afterwards. I'll do B and then I'll recap the whole thing. Hence, show that 3 is the only real root of this equation. Fascinating stuff. Always with these questions, you're going to find the factor and then you're going to divide it through the full function. Let's show you what I mean. X minus 3, 4x cubed minus 12x squared plus 2x minus 6, some have said. So, now this is the old tried and tested, year after year passed down from generations, long division of polynomial work. So I'm not going to explain in detail how to do it. Not right here anyway, maybe somewhere else I will, or I'll direct you to the appropriate sources, but if you go through it, x times 4x squared, 4x cubed, minus 12x squared. Then you have to subtract them off. You get there, you get 0 there. 2x comes down. And what you're going to need a 2 there, looks like. So let's use that. 2 times x is 2x minus 6, and that goes to 0 like you'd hoped. Just run through it once, okay? Very kind of quickly. You need to, the way you do it is you look at the first thing here, the first term, and you think, what do I need to multiply to get to this first term? And the answer would be 4x squared. 4x squared, so you pop it up there, multiply it by that, and you also multiply it by the other term, you get, well, 4 times minus 3 is minus 12x squared. You have to subtract them off and continue in this kind of slightly mechanical way. But, and like I say, no more banging on about it. It's one of those things you just need to sit down and do it a few times. So anyway, what do we get from that? We get that factorized our expression looks like that. That thing at the top. So I could even write that as f of x if you like, if that's the kind of thing you're into, just to really show what's going on here. And well, this is an interesting one actually, because if you have done something like this before, you might have been expecting, well, let's just do a mild side plot over here. What we're going to do, a bit of brackets or something. Sort of side plot, side issues. Is usually these things factorize something like x plus 1, x plus 2, x minus 3, or something like that. You'd have 3 brackets with something inside it. And then you could say something like x equals minus 1, x equals minus 2, or x equals 3. So if you've been doing this for the, you know, since you were born, you'll be used to this. You might, well, it's a little bit more unusual you come across this kind of structure. But that's okay. This is still a quadratic, and we could still potentially factorize that. I can't immediately see a way to do it in terms of it's not difference of 2 squares, it's not factorizing. So I'm just going to use the quadratic formula and see what happens. All right. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. A equals 4, b equals 0, and c equals 2. It's always something to just kind of maybe pause for thought for a moment. Number in front of the x squared is 4. There isn't a b term there. There's not a coefficient. There's nothing with an x. So it's just b is 0. Let's go for it. So b is 0. So 0 plus or minus square root of 0 squared is 0 minus 4 times 4 times 2. 4 times 4 is allegedly 16 times 2. Is that 32? 4 times a times c. Yeah, that sounds all right to me. Over 2a. And would you look at that? Let's just examine that in a bit more detail. Square root of negative 32. You cannot do it. The discriminant, b squared minus 4ac is the discriminant. Talked about that, can't remember, yesterday or 2 days ago. And if it's less than 0, there's no solutions. Therefore, the only root, and then so we'll say something like that, and then we'll say something like, okay, implies no solutions. So x equals 3, the only root. And is that what they asked for? Yeah, exactly. Cool. Quick recap, then on to the A-level question. They gave us this. Someone walks up to you in the street and whispers quietly in your ear, 4x cubed minus 12x squared plus 2x minus 6. And you consider reporting them to the authorities, but you don't, and you just continue with your day and write out factor theorem. That's what it is there. It says, if you pop something in for x, do your monkey punky stuff in here, and it comes out with 0, then x minus that thing you put in is a factor. So if you put in 9 into here and it came out 0, then x minus 9 is a factor. If you put in minus 6 then it would be plus 6 that's a factor. Or sorry, x plus 6, because it's minus minus. Anyway, you get the point of it. That's factor theorem. Put it in. Tell the world that x minus 3 is a factor because it worked out. Then, what you're going to do for part B, find the rest of the roots, if there are any. Always want to do factorizing. Long division. Learn it, know it, do it, get a result. Analyze this part of it. It could have come up like this. You could have ended up being able to get it into 3 parts, but as it happened, this bad boy here, try and smash it into quadratic formula, horror story. Therefore, nothing more you can do with it. And that first chap here is the only solution. That's the only route. Okay. Good. Whew. This is like rapid interval training today. I'm liking it. Next question. Good, nice to see Rachel joining us. Thanks, Rachel, for already subscribing. Everyone else, get involved, do it. There's lots of mathematical joy to come in the following days, weeks, and months. Let's get through this together. So, number 1. This kind of thing. Now, A level, here we go. Now, I don't know how many of you out there are doing any of the new A level specifications. OCR, EdXL, all of them actually now have revamped it, and this is now cropping up more, especially for EdXL one. It cropped up last year, and people collapsed in drama. Collapsed in sort of panic, because it's just people don't really know what this is. So, okay, I'm not going to totally talk about it in detail now, though. That's the recurring theme of this. Let me just do it, give you a flavour for it, and then, again, maybe a more detailed video at some point, or we can direct you. Okay, enough talking. So, I'm going to write it. R equals 1 to 16. 3 plus 5r plus 2 to the r. And actually, I'm not going to write the answer, because here they said show. So basically they want, we need to get to that. I'm not going to use that. That's another recurring theme of these videos, is if you say show or prove, do not touch the answer. But I'm not going to. I'm just going to somehow get there with this. And okay, I said I wasn't going to talk in detail about sigma notation. I'm going to do one absolutely entry-level example of how it works, of what it means. My sigmas, my little things are a bit wonky. They look, I don't know what they look like. Kind of mountain, the Alps on their side, perhaps. There's a sort of mild Toblerone vibe to it. Anyway, so whatever the number is at the bottom, and yeah, okay, maybe we'll call it from x equals 1. Whatever that is, you put that in first. That's the first thing you put in, so you'll do 1 squared. And then you keep putting to the x until you get to the number on the top. So the first thing you put in is a 1, and that's your 1 squared. Then you put in the 2 squared. There could have been more things. I could have put 10 as the top limit, then you'd have had 10 terms. But I'm just going from 1 to 3, doing whatever it says here to each of them, which is squaring it. And then that's it. I can just add them up. 1 plus 4 plus 9 equals 14. So that is 14. That's your turbo warm-up on it. Now I'm going to get going on it with ease. First thing to notice and to do is you need to have the wherewithal to have learned about sequences. Sigma notation sequences often together. 16, r equals 1. 3 plus 5r plus 16, r equals 1. 2 to the r. Put a bracket on that as well, why not? You can split up sigma notation like this. Remember that. It's like an integral. If you had an integral adding over different things, it's integral of x squared plus 10x plus 3, you could split it up and do integral of this thing plus integral of this thing plus integral of this thing. So this can happen, all right? And you could do it. You could sit at home, alone tonight and just really do a few of these and prove to yourself that if you plugged in something here, it would give you the same answer as this. Anyway, banged on about that a little bit too much. Let's actually do it now. So using the sigma notation, the fact that that's summation, because it is summing, that's maybe the key point. Look, I was adding here. It was putting in the 1, adding it with putting in the 2, adding it with putting in the 3. So when we're talking about summation, and we're looking at these things in here, we should have alarm bells ringing. These are sequences. This is an arithmetic sequence. This is a geometric sequence. This is the sum of an arithmetic sequence. This is the sum of a geometric sequence. And this, by look, let's just write out the first couple of terms, all right? So if I put in r equals 1, your first term for this one is going to be 5 times 1 is 5 plus it's 8. If I put in 2, 2 times 5, 13. And if I put in 3, 3 times 5, 18. All right, and this one, well, let's just say that, keep going. Put in r equals 1, 2 to the power 1, which is 2. Put in 2, 2 to the power 2 is 4. And put in 3, 2 to the power of 3, 2 cubed, is 8. Okay, and this is where you need to really bust out your sequences knowledge, arithmetic and geometric. Some stuff is given to you in the formula sheet these days, not everything. Here we go though. The first term here is 8, the first term here is 2. The common difference here is 5, the common ratio here is 2. All right, there's a difference, it's arithmetic, so you're adding 5 every time. There's a difference of 5. Here it's a geometric, so you're multiplying by 2 every time. Splendid. So really, anything else we need? Yeah, you could also say n equals 16. Because there's going to be summing up to 16 here. It's the first 16 terms. And actually, that's all the data that we needed to extract. Because the formulas, if I care to recall, look like, and I'll just write it with the 16 in. The sum to 16 is, well no, I'll totally backtrack on that and just do the actual n for now, just to put the formula down. Sum of n terms is n over 2 times 2a plus n minus 1b. And for geometric, sum to m terms equals a times 1 minus r to the n over 1 minus r. Boxify? You think we should boxify that? Yeah, come on. Why not? Just a little mild divider there to keep them separated so they don't attack each other. Geometric, arithmetic. Geometric, arithmetic. So really, it's just a case of plugging and going. I'm going to plug and go, okay? So I'm going to say, let's do a mild bit of working. 16 over 2 times, 2 times 8 is 16 plus n minus 1 is 15 times the common difference is 5. And in this world, you're going to have 2 times 1 minus 2 to the 16 over 1 minus 2. It looks like, let me just double check that. Yeah, a is 2, 1 minus 2 to the 16 over 1 minus 2. I think I'm pretty happy with that. Let's see if it works out okay. And now, you're really, it's a job of calculations. Can you actually press the buttons on a government-approved calculator in the correct manner? This is what we have to ask ourselves. Plus 15 times 5. It's really just hoping for the best at this stage. Allegedly, that one is 728. And this one looks a little bit more monstrous. 2 times 1 minus 2 to the power 16. Looks like, and then you divide by minus 1 on the bottom, 131070. 131070 plus 728. Add them together, 131798. Is that what they wanted? That is what they wanted. Happy days. How about a quick recap now? Yeah. Before we go on to the next one. Because the next one, turbo recap of this one now, and then we do the last one, do part 2 anyway. So the turbo recap is, this is what they threw at us. They didn't care if it upset us. They were keen. Actually, they probably wanted to make us suffer. We didn't panic though. We assessed the situation and noticed arithmetic sequence and geometric sequence. Because that's what they all look like, by the way. The arithmetic ones are all kind of, 2n plus 6, for example. It's got that vibe about them. And the geometric ones, I don't know, would you write a to the n or something for the geometric? I think it is. They all have a vibe of 2 to the power r or something like that. And actually, the general formula is r minus 1 usually. But anyway, however you put it, it's a power. So anyway, we had to check that. Notice this was a power guy, so it's geometric, and this was arithmetic. Split them up. Try a few terms. There you go, 8, 13, 18, 2, 4, 8. With that, you can get a, d, and n, which is what you need, or a, r, and n for the geometric, which is what you need for your summation formulas. Sum up to 16 arithmetic, sum up to 16 geometric. Bish, bash, bosh, add them together. No time to relax, no time to dwell on the past. We must move on. Bring it home with this guy. There's a sequence. Recursion relation 1. So this is a little bit of a, I sometimes like to throw this one in as well. This type of recursion relation question. So what, and by the way, they're saying the first term is 2/3. And they're saying you get the next term by doing 1, well, let me not write that as the next term, I'll just do it as side work. 1 over 2/3 gives you the next term. Yeah, so whatever term you put in here, you put the first one in, 1 over that gives you the second term. And 1 over that is 3/2. All right. Then you take your 3/2 and put it back in. That's what these recursion ones are all about. And it's a bit similar. There's a numerical methods chapter in the year 2, the sort of year 13 A-level syllabus about this kind of thing as well. So the sequence version of it is pretty similar. We're putting this back in here. So this then for the third term you'd have 1 divided by 3/2. 1 divided by 3/2. If you go back to your primary school musings again, I don't know, maybe I shouldn't be too patronizing about it. This is not always totally easy to realize what you're supposed to do, but if you have 1 over a fraction, you can just flip it again. So actually it goes back to 2/3. And then you're going to be putting 2/3 back in again, and it will come out 3/2. And it's going to keep going. Alright, so we've not actually checked the question yet. All I've done is get a vibe for what the sequence is. And what this sequence is, it's not arithmetic, it's not geometric, it's literally just 2/3 then 3/2, 2/3 then 3/2. Probably the weirdest sequence known to man, but there it is. And sequences can be just a list of numbers. That's the broader definition of them. Geometric and arithmetic are special versions of it. So then let's examine what the actual question is. It says go to 100. Basically sum the sequence up to 100. So again, that's using our sigma notation. This time it's not an actual x they've put here, or they not put the actual function or something there. They're just saying it's like add the first term plus the second term plus the third term plus the fourth term plus the 100th term. Okay, that's the first term, that's the second term, third, So this is their way, this is their apparently succinct and shortened way, but potentially a bit confusing. But can be alright if you get through it. It's their way of saying sum the first 100 terms. So really, the first 100 terms are just going to be 50 times 2/3 plus, in my sort of weird vertical way of doing things, times 50 times 3/2. 50 times 2/3 plus 50 times 3/2. Because if you look at the sequence, there's 100 terms, just keep going back and forward between 2/3 and 3/2. There's 50 2/3, there's 50 3/2s. Bish bash bosh. Calculator fun and happiness. Plus 50 times 3 over 2. The results are in, well, let's just wait, let's just try it again 1 second to make sure I did it okay. 50 times 2 over 3, that looks like it's 103. Oh, sorry, 100 over 3. And the other one, looks like it's 75. Add them together. I feel like my calculator skills could do with being a little bit faster, but potentially 325 over 3. That's what we get. 325 over 3. Okay, rapid recap of that one. They gave you this. They said un plus 1 equals 1 over un. You said, what is un? I mean, what are you even talking about? And we said, and then we said to them, well, actually, that just means the number of the term in the sequence. That's what n is. And so u1 is the first term, u2 is the second term. No jokes about popular Irish pop groups, please. So, first term they gave it to us is 2/3. The second one you get by plugging it in. So 1 over 2/3 gives you 3 over 2. The third one you get by plugging the second back in. Spat out 2/3 again, and what always was happening is you were going back and forward between 2/3 and 3 over 2. Then, once you realised what was going on, had to interpret the sigma notation, sum from 1 to 100 of all the terms, so it's the sum of the first 100 terms. It's not really a formula for that though, because this is not a specifically special sequence. You know, it's not geometric arithmetic, so you just had to think it's going to be 52/3 and 53 over 2s. Add them together. That's the story. And yeah, so the 50, just to recap the 50 one more time. Well, there's 100 terms. This thing's asking to add 100. So in total, there's going to be, if you like, 100 terms that we're adding. Because that's what this guy is asking for. I want you to add the first 100 terms of the sequence. Half of them are going to be 2/3, and the other half are going to be 3 over 2. So that's where the 50 comes from. It means you're going to have half of them, i.e. 50, being 2/3, and the other half being 3 over 2. You know, depending on what the sequence was, it's not always going to be like that for this type of question. You might get a sequence that goes through 4 different numbers instead of just these 2, or it goes through 10 numbers, and you might have to come up with your own brain power way of adding them all together. You could sit there and do 2/3 plus 3 over 2, 2/3 plus 3 over 2 plus 2/3 100 times, or you could just think of it, well, there's 52/3 and there's 53 over 2s, so the way to get the sum of it all is 50 times 2/3 plus 50 times 3 over 2s. Okay, smashed it for today. Good stuff. My brain's feeling more energized already. Thanks for joining me. Keep following me, subscribing, tell people about it. If anyone, you know, if you feel like anyone's just lazing around in bed and should be up at 10 AM do maths, do tell them about it. Get them involved here. Thanks very much, guys. Any questions, let me know. And yeah, see you again tomorrow, 10 AM. Bye-bye.